All right, so in this video, we're going to go over the free body diagram worksheet. So when solving free body diagrams, there's not a set order to solve things in. It just depends on what information you're given as to what is easy to do first. So starting off with this first one, we are given the air resistance going up of 0.1 and the force of gravity of 0.1 going down. So we're not given the mass, we're not given acceleration, and then this symbol at the bottom, this is sigma F, or the sum of the forces, and that stands for net force. Right? So the two ways you can find the net force is if you have the mass and the acceleration of the object, you can use F equals ma to solve for the net force. We don't have those right now, so we can't do that. However, we do have both of our arrows labeled, and we can find the net force that way. So for opposite sides, we're going to subtract them. And so in this case, we have 0.1 for both arrows. So if we subtract them, we're going to get a net force of 0 newtons, right? Versus over here on these two, we don't have our arrows, so we wouldn't find our net force by subtracting them. We would find our net force by multiplying mass times acceleration to get our net force. So then the next step you can do is finding your mass of your object. So typically you're going to be either given the mass or the force of gravity. So you can use the same formula and then for finding both, you'll plug in things differently depending on what you have. So it's force of gravity equals your mass times acceleration due to gravity. And this G right here is 9.8. So in this case, we have force of gravity is going to be 0.1 newtons equals your mass of which is what you're finding times 9.8. So anytime you're finding the mass, you're going to end up dividing force of gravity by 9.8. Right? So in this case, you're going to divide 0.1 by 9.8, and that is going to equal 0.01 in the masses in kilograms. So that is the mass of our object. So again, anytime you're finding the mass, you're going to divide force of gravity by 9.8. Then to find the last thing here is our acceleration, you are going to go back to this F equals ma formula. And you have now the net force and you have your mass, so you can solve for acceleration. So your net force is 0, your mass is 0.01, and you're solving for acceleration. So you would divide both sides by 0.01, which ends up being 0. So anytime your net force is 0, your acceleration will also be 0. All right, so moving on to question 2. All right, so for question 2, like I said earlier, you don't have your arrows here, you just have your mass and acceleration. So the first thing you could do is use that F equals ma formula to find your net force. So we'd have F equals ma, your mass is 10,000 times your acceleration of 8 down. So this would be equal 80,000 newtons. And the direction it's going to go is down since your acceleration was going down. All right, and what that means, that 80,000 newtons down, means this down arrow, or the force of gravity arrow in this case, is going to be 80,000 newtons more than your up arrow. So these are not going to be the same like the first one was. So now we have all three of these information. We want to go figure out what the arrows are. So the first one you can do, and always a safe bet, is finding your force of gravity next. So again, we're going to go back to this formula here, the force of gravity equals mass times 9.8, and solve for it. So force of gravity equals your mass of 10,000 times 9.8, which is going to equal 98,000 newtons, right? So that is our down arrow. Now we want to find our up arrow by subtracting 98,000 minus 80,000 newtons, because we again want this down arrow to be 80,000 more than the up arrow. So we'd have to subtract them to know the difference. So 89,000 minus 80,000 is 18,000 newtons. So if you go back and you say have your arrows, you subtract 98,000 minus 18,000 is going to equal that 80,000. All right. For this third one in the row, I'm not going to work this one out, but it's the same idea as the second one, except for now your net force is going to go up because your acceleration is going to go up. So that means your air resistance force the up arrow is going to be greater than your force of gravity going down. So that's the key difference between B and C. For the next row, We now are bringing in 3 arrows to these diagrams. So the idea is still the same. Start off with finding, if you have all of your arrows labeled, find your net force like we did in the first one. But in this case, you have your up and down labeled, they subtract equals 0, and you have 9,000 left, but nothing going to the right. So that means your net force is going to be 9,000 newtons to the left because there's nothing to subtract it from, right? Same with these ones over here. Like, we're given our net force of 124 newtons right, and there's no arrow going to the left. So that means all of that 124 newtons is your right arrow. All right. So now for these, a safe next step is going to be finding your mass for this first one. So again, that's your formula, F equals mg. And you can find your mass, and then you can use F equals ma to find your acceleration of your object. With this one, you're given the mass. So again, you're going to use F equals mg to do that. You're just solving for m this time. Or sorry, you're solving for mg instead of m because you have the mass. And then again, you're going to use F equals ma. Okay? For these, your normal force, if your normal force is across from force of gravity is above it, those are going to be the same. Like you can see here, these are the same, these are the same. These will equal because your net force can only go one direction for the diagrams we work out. So since this is going to the right, that means these need to be the same number for that to work. Right? And then the last row, and mainly just look at this last one because that's the only one with 4 arrows. So again, the idea is the same. Go ahead and multiply those two out to get your net force. It says it's going to the right, so that means this right arrow is going to be the bigger arrow. So the difference between these 2 arrows is going to equal the net force. So we'll go ahead and do that real quick. So F equals ma is 2,000 times 2 for your acceleration, which is 4,000 newtons. And it's going to go to the right since it says your acceleration is going to the right. And those will always go the same direction. So 4,000 newtons right. So that means if I go back, I want this right arrow to be 4,000 bigger than the left one. So I'm going to subtract 14,000 minus 4,000, and this will be 10,000 newtons. Right? Then I can go find my force of gravity using Fg equals mg, and then that will be the same for my normal force. Okay. Hopefully this helps, but if you still have questions, feel free to shoot me an email.